In this video, we will solve quadratic equations using the method of square roots. So first of all, here's our general method, and we will do some examples after this to explain in more detail, give some more concrete examples of using this method. But in general, we have two different types of quadratic equations. We have ones that have that middle bx term, so if you're thinking ax squared plus bx plus c equals, and then either maybe y or 0, then if the equation has this bx term, the first step is going to be to convert this equation to vertex form. And let me remind you of vertex form. That's the one that would be a times x minus h squared plus k equals y, or perhaps in this case 0 if we're solving equation set equal to 0. If we don't have a bx term, then, or if the equation is already in vertex form, then you move on to this next set of steps. So in general, we will try to isolate the part of the equation that's squared, that has the exponent of 2 on it. We will use a square root to cancel the square, try to solve for x, and then remember this plus or minus sign. I'll explain that a bit more in the examples, and also remember to simplify square roots. Okay, so first of all, let's do an example. Let's solve x squared minus 7 equals 0. All right, so we are trying to find the solutions for x that will make this equation true. And we've also seen the connections to parabolas. So by having this equation equal to 0, what I'm doing is looking for the x-intercepts for a parabola. All right. Now we've seen in many cases these will have 2 x-intercepts. In some cases there will not be any x-intercepts, and then in some cases you might have exactly 1 if the vertex of the parabola actually lies on the x-axis. All right, so we could be looking for no real solutions, maybe they're imaginary, or 1 solution or 2 solutions. Okay, so following along with the method that I just described, the first thing you want to do is isolate the part of the equation that's squared. So here the x is the thing that is squared, and I want to get that by itself. So I'm going to do that by solving for that part, or I'm going to use like backwards order of operations, the same as you would if you were solving a regular linear equation. So I'm going to add 7 to both sides. And then I would get the equation x squared equals 7. Okay, so the next step is to use a square root on both sides of the equation to cancel this square. All right, so in other words, let me put this off to the side real quick. The square root of 5 squared is just 5. A square root and a square will cancel. All right, and the explanation is that the square root of 5 squared is the square root of 25, which is just 5. Okay, so the square root of 3 squared would just be 3, and the square root of x squared would just be x. Okay. Now you can look at this equation too, and also think back to the examples in the previous video with thinking about the definition of square roots. So remember that this is asking what number squared will give 7, and we've seen that there are always 2 numbers that are going to work. There's one positive and there's one negative. All right, so I'm going to square root both sides of the equation, and on the left I would just get x, but on the right I need to somehow indicate those 2 numbers. So right now I'm only picking up the principal root, which is just the positive square root of 7. But I also want to make sure that I acknowledge that the non-principal root, the negative square root of 7, is also a solution. So anytime you solve equations with these square roots, usually right at this step, after I've put this square root in, I try to remember to put a plus or minus sign in front of the square root. And then that's indicating the two solutions, the principal one, the positive one, and then also the negative one. And just for this one, I won't do this every time, but I do want to check these two solutions to make sure that they work. All right, so notice in the original equation, I'm going to substitute in, I'll do the principal root first, the positive square root 7. And I want to check if that squared minus 7 does equal 0. All right, so square root 7 squared is square root 7 times square root 7, which is square root 49, which is 7. So I end up with 7 minus 7 equals 0, and that checks out. Then I also want to check the non-principal root, the negative square root 7. So now negative square root 7 times negative square root 7, well, a negative times a negative is a positive, and then square root 7 times square root 7 is square root 49. So that again becomes 7. So in the case for the non-principal root, we also end up with 7 minus 7 equals 0, which also checks out. All right, a second example. So step 1, isolate the part of the equation that's squared. So now when you see 3x squared, only the x is actually squared. This would mean 3 times x squared, or in other words, square the x first, then multiply by 3. So it's the x squared part that I want to get by itself. Okay, so I want to get rid of the 3 and get rid of the plus 6. So I'm going to do that by solving for x squared. So I'm going to move 6 by subtracting it first. So 3x squared equals 6, negative 6. Right? And then I want to divide both sides of the equation by 3. So you would get x squared equals negative 2. All right, now if you pause here and think about this, what number squared would equal a negative number, negative 2? There's no real number that's going to work here. So we're actually looking for an imaginary solution. And if you go back to this original problem, if you graph the parabola y equals 3x squared plus 6, you're going to see that it doesn't have any x-intercepts. There are no real numbers where it crosses the x-axis. Right? So those are all clues that we're looking for imaginary solutions. So now we move on to the next step. Well, we've isolated the part that's squared, and now you would use a square root on each side of the equation. Okay, so on the left, square root of x squared is x, and on the right, even though this is imaginary, I still want to think about the principal and non-principal roots. So I'm still going to put a plus or minus sign in front of the square root negative 2. Okay, and then finally, I need to make sure that this square root is fully simplified. So this would be plus or minus, and then this is imaginary, so this is going to be square root negative 1 times square root 2, and that's plus or minus I times the square root of 2. And then square root 2 is fully simplified. There are no perfect square factors of 2. So my two answers would be plus or minus I square root 2. Now, how would you do a check for this one? I want to walk through that. So let's check. We have two answers to check. So we've got plus or minus I square root 2. And let's check the principal root first. So I want to do 3 times I square root 2 squared plus 6 and make sure that equals 0. Okay, so using order of operations, I want to square this first. So I'm going to do I square root 2 times I square root 2. All right, so I can use the commutative and associative properties to move things around in there. So I actually want to do, I'm going to do I times I, and then go back and do square root 2 times square root 2. All right, so I times I is I squared, And if you remember in the previous video, we had a definition that said I squared was equal to negative 1. Right? So I squared is negative 1, and then square root 2 times square root 2 is 2. So now I have 3 times negative 2 plus 6, and that gives me negative 6 plus 6, and then negative 6 plus 6 is 0, so that checks out. All right, the check for the negative root is very similar, so this would be negative I square root 2, and then these would each be negative. And then I'm going to again use the commutative and associative property, so I'm going to choose to put those negatives on the square roots of 2's. All right, so I would still have I times I is I squared, which is negative 1, and now negative square root 2 times negative square root 2 is going to be positive 2. Okay, negative times negative will still be a positive. And then the rest of the check would look the same. We would get negative 2 times 3 is negative 6 plus 6 is 0. All right, how about 15 equals 4 plus 3x squared? All right, so this one looks a little bit different, but I would still follow the same steps. So notice, again, as with the other examples, I don't have a bx term. Right, so all of the examples I've done so far have been missing that bx term. We just have an x squared term and then some constant numbers. All right, so we'll deal with the ones that do have a bx term later. But for now, we would jump in at the step where you get the part that's squared by itself. So it's on the right side of the equation this time, but I'm still going to do the same thing. So I'm going to move everything away from it. So I'm going to subtract 4, and 15 minus 4 is 11. And then on the right we have 3x squared. Next you would divide by 3. And knowing that I'm going to be using square roots, I would rather do square roots with fractions than decimals, because in most cases the simplest answer is going to need this fraction, not the decimal, to be able to go from here. All right, so basically for any of these where you're solving with square roots, let's stick with fractions rather than decimals. So I'm going to leave this as 11 thirds, and then on the right I have x squared. Okay, so the part that's x squared is by itself, so I will use a square root now on both sides. On the right, square root of x squared is x, and on the left I need to remember to take the positive and negative square roots, so plus or minus square root 11 thirds. And then we're almost done. We have x by itself, but I do need to make sure this square root is fully simplified. All right, so the square root of 11 thirds. In one of the previous videos, I reviewed how to simplify these. So you would rationalize. I'm going to multiply by square root 3 over square root 3, and that's going to be square root 33 over 3. Okay, and then 33 is 3 times 11, so I know there are no perfect square factors in that square root. So my final answer, x, would be plus or minus square root 33 over 3. All right, how about 2x plus 3, that quantity squared, plus 7. Now this one, you may think that there's a bx term, because I'm looking here and I see this 2x, which looks a little bit different, but this is actually not in standard form. You may recognize this as vertex form. Okay, so it's kind of like a times x minus h squared plus k. It's a little bit different because we've got this 2 in front of the x, but it's closer to vertex form than anything else. All right. So for this one, I'm still going to jump in at that same step with getting the part that's squared by itself. But this time the thing that's squared isn't just an x, it's actually an entire parenthesis. So that's the part I want to isolate. So the thing that I really need to do is move the 7 first. So let's subtract 7 from both sides of the equation. And then you get 2x plus 3 squared equals -7. Now it's really tempting to actually use FOIL and figure out what 2x plus 3 squared is. And in this case, we don't actually want to do that. We want that square so that I can use square roots to cancel that. If I were trying to solve by factoring, or if I wanted to get this into standard form, those were some problems we did in the past where we did use FOIL to figure out what this is. All right, but now for this method, we've got the part that's squared by itself, and the next step is to use a square root to cancel that square. So on the left, the square root and the square would cancel, and we're left with 2x plus 3. And then on the right, I need to remember the principal and non-principal roots. So this would be plus or minus square root -7. And I can already see that my answer is going to be imaginary because of the negative number inside that square root. The left looks a little different this time. The previous examples have already been solved for x at this point, but here we have a little bit more work to do. So I'm going to try to get x by itself. So I'm going to subtract 3. And on the left we have 2x. The right looks like a little bit of a mess, but actually these are considered to be not like terms because we've got an integer number and we've got a square root number. So I can't really combine those. And what you'll usually do with those is put this integer number first, so -3, then the plus or minus, and then you put this square root part next. All right, then we're still solving for x, so you would divide by 2. All right, and then everything on the right gets divided by 2. All right, we have two terms. We have the -3 and the plus or minus square root -7, so those both get divided by 2. Okay, so x equals this whole thing on the right. Almost done, but I still need to worry about simplifying this square root. All right, so I know off to the side here, maybe I'll do the work for this. So square root -7 is square root -1 times square root 7. Square root -1 is I, and square root of 7 can't be simplified anymore. So putting that back into my equation, I've got x equals -3 plus or minus I square root 7, and all of that is divided by 2. Okay, so that's the final answer. All right. A check for this one, I probably, to be honest, wouldn't even attempt because there's so much work to do with this one. It's not horrible, but if I were you, I'm trying to think, I probably wouldn't check these unless I actually got to the test, and then maybe on a test you would check this. So I don't think I'll cover that in this video, but we can talk about it in class if you would like to see how to do that. All right, so we'll end with one more example. Again, this one doesn't really have a bx term because it's not in standard form. This is closest to vertex form. So I'm going to try to get the part that's squared by itself. All right, so we're trying to get this whole parentheses by itself. So first of all, add 8 to both sides. And then we have 3x plus 4 squared equals 8. Next, square root both sides of the equation. And on the left, the square and square root cancel, and that leaves you with 3x plus 4. And on the right, we have plus or minus square root 8. Before I jumped over and I solved for x next, maybe here I'll simplify the square root before I do that. So you can do this in either order. So I know square root of 8 is square root 4 times square root 2, so that's going to be 2 times square root 2. So we've got 3x plus 4 equals plus or minus 2 square root 2. Next, solving for x, we're going to subtract 4, and then you have 3x equals, and then this square root term and the minus 4, the integer term, can't really be combined, so we would normally write that -4 first, and then plus or minus 2 square root 2. Right? So remember, like order of operations, if you tried to actually do this addition or subtraction, there's really two issues here. First of all, you have to make a decision about this plus or minus sign. Are you going to do -4 plus 2, or are you going to do -4 minus 2? The other issue is that order of operations says that we have to multiply first, so I would really need to do this 2 times square root of 2 before I can think about adding or subtracting this -4. So because of those reasons, we're just going to leave it like this. All right, and then last step, divide everything by 3 to get x by itself. All right, so x would equal -4 plus or minus 2 square root of 2 all over 3. All right, so to check that everything's done, I have plus or minus, so I know I've gotten both of the square roots. I fully simplified the square root part, and I have x by itself, so that's done. Okay, in the next section, we'll talk about solving equations that do have that bx term that are written in standard form. We need to convert these to vertex form before solving. So I'll save this for later, but you already do know how to do this. You would use those two formulas for h and k, right? Figure out h and k, and then you could write vertex form and go from there. So it's just a bit more to add on, but I think it's too much for this video, so we will stop with these examples. All right, so as you're doing these, go back to the method if you wrote this down, or if you want to review in this video. These are the steps for solving using square roots, and up to this point we've skipped over this first step, converting to vertex form, and we focused on these last steps. Isolate the squared part of the equation, use a square root to cancel the square, solve for x, get it by itself, and then just two reminders: don't forget the plus or minus sign when you're adding in square roots, and then also make sure that the square roots are fully simplified.